This is Steve Piloff from George Mason University. So frequently, time zero is today, but it doesn't have to be. Some cases it might be in the future, some cases it might be in the past, but the way to identify a good time zero to use is setting up a timeline and then defining the earliest relevant time as time zero. And so I often like to think of jumping into a time machine and getting out at the appropriate place on a timeline. So let's take a look at a couple of examples. How much must the Lee family have saved in 10 years? So we want to know how much they'll have saved in 10 years. Diana's going to start college. Annual room and board payments of $50,000 will be necessary, with the first payment due in 10 years. So in 10 years is the first 50, and the last is in 13. So that means they'll also have payments in 11 and 12, and the discount rate is 10%. Well, first of all, the way we think about this is they have money saved up, and if they're going to need to make payments, they're going to withdraw 50. So they're going to get 50 to them at 10 years, 11 years, 12 years, and 13 years. And so, again, you have when they start and stop 10 and 13. You put them in your timeline, you can count that there's 1, 2, 3, 4. But let's get into our time machine and jump forward 10 years. So get in our time machine, we get out here, and this is our new time zero. We jump out, and we want to know on that day, 10 years from now, we jump out of our time machine, how much money will the Lees have? And they'll need enough so that they can withdraw 50 right away, 50 in a year, 50 in 2 years, and 50 in 3 years. And that, when we get out of our time machine and look at it that way and retime it, is simply wanting to know the present value of a 4-period annuity due, because there's 4 payments, 50,000 with a discount rate of 10%. 50 plus 50 over 1.1 plus 50 over 1.1 squared plus 50 over 1.1 to the third. And that's pretty easy to do. Let the calculator do all the work. 4 payments. They start right away. 50,000. Interest rate of 10%. Present value, that's 174,343, and that's how much the Lees need to have saved. Let's take a look at another one. Dirk's going to retire in 15 years with 500,000. So he's going to have 500,000 in 15 years. How much can he withdraw each year? He makes equal annual withdrawals for 10 years. So we know he's going to be getting 10 checks from this 500,000. The first one takes place 1 year after he retires. Well, if he retires in 15, then we know in 16 is his first one. There's 10 of them, so we know they're in 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. And the discount rate's 10%. So all this stuff's going on in the future, so we want to get into our time machine, and we get out in 15 years. That's us getting out, and we say, aha, I have 500,000. In 1, 2, 3, 10 years, each year I want to withdraw money. How much can I withdraw? And we can see that what we're trying to find is the payment associated with a 10-period annuity that has a present value of 500,000 and discount rate of 12%. So we've taken this problem and by retiming it, put it into terms that we have tools to use to solve. So there's 10 payments. We're in end mode because the next one's 1 period after our reference point, which our new time zero is 15 years from now, but the first payment is 1 year after he retires in 15 years. The present value of all the money he's going to get is 500,000, so set PV equal to negative. It's the opposite. 12% discount rate, and Dirk can withdraw $88,492 each year for 10 years, starting 1 year after he retires, if he retires with $500,000.